Oh, weird. Okay.
I need to run it back too. Monty says all.
All right.
So I'm trying to make a trade.
Assume that the readings at freezing on a batch of thermometers are normally distributed with a mean of 0 and a standard deviation of 1. So I'm going to put 0 and 1. That's pretty much the standard. A single thermometer is randomly selected and tested. Let Z represent the readings of this thermometer at freezing. What reading separates the highest 38.78% from the rest? So we want this to the right, 38.78. So I got to find out what 1 minus that is. It looks like it's point. I'm going to go to inverse. And it should be 0.6122. And so to the right is that number. The z-score is 0.285. Is that okay? Now the scores on a standardized test are normally distributed with a mean of 110 and a standard deviation of 25. The test score is, what test score is 0.9 standard deviations below the mean? So we want to be, basically take 0.9 of 25 and subtract that from the mean and get the z-score of that. So 25 times 0.9 is 22.5. Take 110 minus 22.5. My calculator is awful. 87.5. Whoops. For the z-score. No, I think it's just 87.5 is what they want. Yeah. So remember 0.9, if that's the is the z-score. So 0.9 represents how many standard deviations you are from the mean. And if it's below, that means it's subtracted. No. I took 0.9 times the standard deviations. And then that was 22.5. And so I went 22.5 beneath the mean. That's a test score that's 0.9 of 25 less than the mean. Does that make any sense?
What was the answer of the 25?
I took 110 minus 25 times 0.9.
22.5.
Yeah, so
Inverse?
no, just subtract that from the mean, and that's the answer. You want to know basically what number has a z-score of negative 0.9. So you could, just think of it this way. Where we have z is equal to a value minus the mean over the standard deviation. So 0.9 was the z-score. We want to know the value. The mean was 110, and the standard deviations was 25. So just solve that equation for x.
Can you put this on our test, the equation, or
Yeah.
memorize it?
Yeah, I'll put it on.
Okay, thank you. It really does.
You said that song?
I'm thinking about it. Sending that to Jake, because I have Herbert.
I mean, that's strange.
So I just took 110 minus 0.9
We're
of
doing about the
25.
same. Which one? Is that I have Herbert?
The systolic blood pressure of adults in the USA is nearly normally distributed with a mean of 120, a standard deviation of 20. Someone qualifies as having stage 2 high blood pressure if the blood pressure is 160 or higher. Around what percentage of adults in the U.S. have stage 2 high blood pressure? Give your answer to 2 decimal places. So that would be
Like
So we
2%.
just didn't measure.
probably to the right.
We just measured.
I could probably be good with that. Let's see if it'll accept this.
He has no meaning.
What? Oh, I'm supposed to keep going. So I think,
Yeah, you just gotta go a little farther. This is the one where you had to go like really far.
Hopkins.
if you sample 2,000 people,
The Falcons suck.
oh, yeah, this one is one that you're not ready for.
No, we actually did get this, and this one just sucks. Because no, when you got it, it's supposed to be like whatever you got for what's over 160, you multiply that by like 2,000.
Yes, yeah.
Yeah, and it's like 8 or 7 people. But whenever you put that in, it like never did it. It was really dumb.
Yeah, it's actually tricky. So yeah, this is like really not going to work, is it? So you just took that. We had this number times 2,000.
Yeah. And it should be like 8. It should be like close to 8.
I got 56.
Or 6. Same thing.
Maybe we'll try that. Stage 1 blood pressure, high blood pressure is specified as between 140 and 160. What percentage of adults qualified for this? So I already know this 0.0228 is above 160. If I put in 140, let me do that. It's 0.0228. And the number will be 0.1587. So 0.1359. So many parts. The doctor tells you are in the 30th percentile of blood pressure among U.S. adults. So I'd go to inverse, 0.3. So we would have a blood pressure of 109.52. Let's see how we did. We only got a quarter. Everything was wrong except for this one.
Woo!
So let's see what the answers are. Oh, they want it as a percent. So I had this as a decimal. So we want this as a percent. You got to be careful of that. And I assume, so what was this thing's problem? 46. So they must have just had us round. No, I don't know what they did here. So 0.0228
I got
times.
46.
Yeah, I must have typed something wrong. I wonder if I did 0.028.
That could have done it.
That's what I did. I missed it. I missed it too.
Simple mistake.
Yep. So yeah, 46. You were right. Or didn't you say 8 before, Nate?
I don't remember the question. I remember doing
Yeah, it might have been different numbers.
Yeah.
And then what is this? They want a percent, so I'm guessing 13.59%.
Bamboozled.
That's
Oh,
right.
yeah.
All right. All the credit. Okay, assume that the readings at freezing on a bundle of thermometers are normally distributed with a mean of 0 and a standard deviation. Didn't we do this? Find P81, the 81st percentile. This is the temperature reading separating the bottom 81, yeah?
Do it. Oh yeah.
So that would be 0.878. Oh wait, what do they want?
No, that's right. That's right.
That's right. That's correct. The physical fitness of an athlete is often measured by how much oxygen the athlete takes in, which is recorded in milliliters per kilogram. The mean maximum oxygen uptake for elite athletes has been found to be 60 with a standard deviation of 8.7. Assume that the distribution is approximately normal. Find the probability that an elite athlete has a maximum oxygen uptake of at least 73.1. So that would be the probability there or to the right. So anybody there would be below that. 93% would be below that, but 0.0661 is above. Find the probability that an elite athlete has a maximum oxygen uptake of at most. I think I did that wrong. It wasn't at least, it was at maximum. So I should put the lower number.
That should be 193, right? Yeah.
And this should be 51.3. And that should be,
120.
yeah. Missed something.
Maybe you're right the other time.
And the probability that an elite athlete has a maximum
I think you were right the other time.
of at least. Yeah.
Yes, that's the bare minimum.
Yeah. I just, the maximum threw me off. So I
Gotta read it a couple times.
yes. Yeah, I should write the first one. The mass of a species of mouse commonly found in houses is normally distributed with a mean of 20.9 grams with a standard deviation of 0.13 grams. 3 parts. What was the probability that a randomly chosen mouse has a mass of less than 20.73? So that's 0.09 per 5. What's the probability that a randomly chosen mouse has a mass of more than 21? That'd be 0.2209. And was the proportion of mice that have masses between 20 0.8. Gotta put that number in. Well, let me do the big number first because I'm gonna do the big number minus the smaller one. So that should be 0.6778 minus 0.2209. So I have to put that into my calculator. I got 0.4569. Inverse normal, 15% of all mice have mass of less than 20.765189999. All that. I don't know what they want. 5.1819. Yay. Is that okay? Let X represent the full height of a certain species of a tree. Assume that X is normally distributed with the mean of 183.9. Standard deviation is really 3.5. Find the probability that, the full height. Find the probability that the full height of a randomly selected tree is greater than 193. So that would be 0.0047. That's the last one. And her math 135 class, Professor Elaye found that the mean score of the first exam was 63. Suppose that the scores are normally distributed with the standard deviation of 12. What is the probability that the score will be less than 52? 0.1717. What is the probability that the randomly selected score is more than 25 or 65? 0.4228. And then between 52 and 65, well, I'm going to take to the left of the high one and subtract that from that. So this is going to be 0.5662 minus 0.1797. 0.3865. There we go. Easy.
Yeah. Once you actually know to use inverse norm or like normal, so you have to.
Yes. Good. So this is your
It's pretty much our test.
half of it,
Half of it.
What is the other half?
The binomial.
the binomial.
Can we go over that on Thursday?
Yes.
Oh. In student council, we were talking about what to do for home, like to be on homecoming or other things. What do you guys think of like a classroom Among Us game? Yeah. Like a tournament thing. What?
You can only get 10
teachers
people.
play. But there'd be like 2 tournaments.
Like, brackets?
Yeah, there'd be brackets.
I'm saying we come to school and we actually do schoolwork. We go home.
So fun.
You walk in here every day and you're like, let's call it a day.
Well, it is that time of day, right?
Then on
Sometimes
home,
I walk in here for web design,
you just open the window.
I'm already like,
Who
let's call
opened
it a
this
day.
window?
Because I can barely breathe, it's so hot in here.
What do you do? What should do? Post.
You guys can use this calculator. If I find the other version, you guys use
That one sucks.
I think the other one had a binomial in there. I even had like a spreadsheet that I was building, and I was just like, why am I building a spreadsheet when there exists?
That's true.
I'm like, I just wasted so many
I
hours.
just wasted so many hours.
I'm not doing that.
I like the calculators, man.
But you guys got your own calculators, just make sure you know how to use inverse normal and normal, binomial, CDF, binomial, PDF.
We gotta go over the binomial.
You're gonna have some of those questions like we had with those colored normal CDF ones where you kind of had to use the symmetry and
Oh, the eagle one?
where I don't tell you what the mean is or where the cutoffs are, but you just have to know that they all add up to 1
Yeah.
and that it's symmetrical.
You are incredibly uneducated loud.
Says the craven clay-brained horn beast.
We're a flower, fat kidney, blueberry head ass booger.
Says the goatish, flat-mouthed, fin-sucked looking coxcomb.
What are you talking about?
They're flying.
The what?
We're flighty. Rat battle. Ancient Shakespearean thing.
Oh, that's right.
Jarring, then
Oh, hello, Fernanda.
horn beast. Look at that.
I think it's triple N.
Triple what?
Triple N.
Oh.
I just went over that thing that you guys had last class, and I was showing you the calculator.
And I am a horn beast.
We will go over the binomial distribution again
She's not in there.
It's the
next class.
idle-headed.
But if you're there, you're good to go for today. I'm going to close the video so that it processes and then I can upload it to YouTube.
I'm always strapped now.
Please look. Face
Have a good day.
Oh, Andrew. Meg said that you and Gabe were, you know how you had